the Rational Zero Theorem. So our objective in this video, we want to use the Rational Zero Theorem, after we learn what it is, of course, to find possible rational zeros. Let's recall that rational means it's a number that can be written as a fraction. Those are rational zeros. So what do we know coming in that's going to help us? Well, we know what a polynomial function is. It's a function of the form f of x equals coefficient times x to the n plus coefficient times x to the n minus 1, etc., all the way to a constant term. And the coefficients are real numbers. The coefficient of the variable right here, a sub n, the coefficient of the variable with the highest power is called the leading coefficient. If we remember, if we write these in order from highest power to lowest power, that's in standard form. And the a sub 0, the final value here, is the constant term. All right. When finding zeros or roots of a polynomial function, these zeros can be rational, which means they can be written as a fraction. They can be irrational, which means they cannot be written as a fraction. For example, the square root of a prime number, the number pi, the number e, those are examples of irrational numbers. And or they can be imaginary numbers. We would use the letter I. Okay, as we know, our real zeros and our reals contain both the rationals and the irrationals. Our real zeros will show up on the graph as x-intercepts. Obviously, our non-real or imaginary will not show up as x-intercepts. So here's an example. This is a factored polynomial showing all factors of which there are 1, 2, 3, 4, 5, 6. So this is a 6th degree polynomial. Okay. Notice in factored form, this one gives us a rational zero of -3. This one gives us a rational zero of 1/2. This factor gives us an irrational zero of -√2. This factor gives us an irrational zero of √2. All of our rationals and our irrationals are members of our real numbers. These are going to show up as x-intercepts on a graph, these 4 in this example. These two factors are our imaginary roots. This factor, the 0 is 4 minus 5i, and this factor, the 0, is 4 plus 5i. I believe we've seen prior that imaginary roots always comes in conjugate pairs. Okay, so 4 minus 5i is always paired with 4 plus 5i, and vice versa. 4 plus 5i is always paired with 4 minus 5i. These are our complex imaginary zeros, and these are our non-real zeros. Okay, so we got a lot of vocabulary figured out here. A lot of remembering of how our numbers are laid out. Let's take a look at the Rational Zero Theorem. And then we'll do, I believe we've got 1 or 2 examples. Slide up here. There we go. Okay, the Rational Zero Theorem, it's a tool. It's a tool that can be used to make a list of all possible rational zeros. Okay, all of these, all the zeros that can be written as fractions of a polynomial function that has integer coefficients. So we're getting kind of specific here. The polynomial function has to have integer coefficients. And we're going to be making a list of the zeros that are rational. Okay, not irrational, not complex imaginary, but the ones that are rational. Let's remind ourselves, some polynomial functions don't have any real zeros at all, rational or irrational. okay? But this is going to be used for those polynomials that have integer coefficients to list all of the possible roots that are rational. And how is it done? If P is a polynomial function with integer coefficients, all possible rational zeros must be of the form P over Q simplified, where P is a factor of the constant term. Okay, let's go up here. P is a factor of this term, the final constant term. Go back down. And Q is a factor of the leading coefficient. Go back up here. Okay, here's our leading coefficient. Q is a factor of the leading coefficient. So simply put, all possible rational zeros are equivalent to the factors of the constant term divided by the factors of the leading coefficient. So if it has any rational zeros, this is how we'll find them. Let's do a couple of examples because even to me, that's a bit confusing in words only. Okay, so let's take a look. Let me get my papers together. Okay. List all possible rational zeros of this fifth degree polynomial, 4x to the fifth plus 12x to the fourth minus x minus 3. Then we're going to graph the function using our graphing calculator to see which are actual rational zeros. Okay, we'll take a peek. So let's see. We know that our possible rational zeros, right, is equal to, well, we're looking at our constant term and its factors and our leading term and its factors. Let me slide the paper down a touch. The factors of -3 is positive or -1 and positive or -3. The factors of 4 are positive or -1, positive -2, and positive -4. Those are the factors of our constant term and our leading coefficient. So that means we've got positive or -1 and positive or -3 in the numerator. And we've got positive or -1, positive or -2, and positive or -4 in the denominator. Okay, so let's take a look. And we use positive and negatives to get them all because we can do combinations. Positive 1 times positive 4 is 4, -1 times -4 is positive 4, etc., etc. So I do it, I take this numerator and I apply it to every denominator. So there's one possible rational zero. Here's a second possible rational zero, positive or -1 divided by positive or -1, positive or -1 divided by positive or -2, positive or -1 divided by positive or -4. I've used up this numerator with all possible denominators, and I'll kind of put little arrows. And now I'm going to repeat with this numerator. So positive or -3 over positive or -1, positive or -3 over positive or -2, and then positive or -3 over positive or -4. Okay? That's all possible. Now we can simplify some of these. Positive or -1 divided by positive or -1 is positive or -1. This one's going to be positive or -1/2. This one's positive or -1/4. This one is positive or -3. This one here is positive or -3/2. And this one is positive or -3/4. So we have a total of 12. Positive 1, -1, positive 1/2, -1/2. We have a total of 12 possible rational zeros. Okay? Total of 12. If this fifth degree polynomial has a rational zero, it will be one of these 12. Okay, done deal. That's what this theorem says. Okay, the rational zero theorem says if the polynomial with integer coefficients has a rational zero, that's how we list them all. Okay, so let's take a look at this polynomial, and we'll go into our graphing device, and we're going to put this polynomial in here. So I'll clear out what I have, and let's see which of these 12 are actual rational zeros. Okay, so let's see here. 4x to the fifth plus 12x to the fourth minus x minus 3. Here's our graph. Maybe, there it is. Okay. So, we have 3 real number zeros. That includes rational and irrational. Okay. And let's see which of these, which of these total of 12 rational zeros is actual in the graph. Let's first off test this first on the left. I'm going to go to calculate. I'm going to calculate a 0. And I want it to be, I want to look to this one over here. So come on down. Where is my, whoops, I think I've gone too far. Where's my x, my left bound? I'll tell you, let's make it a little bit easier and let's zoom in here. Let's check my window go from -5 to 5. Make life a little bit easier to see it. Okay, there we go. All right, I'm looking over here. So again, second calc. Okay, second calc. The 0. I want to go over to the left bound over there. I want to be below that one. I got to figure out, here we come, maybe. My cursor's up in here lands somewhere. I seem to have misplaced. Where did it go? Maybe I'm skipping it. Looks like I'm missing. Let's go back to my window again. Let's do a little bit higher from -10 to 10. Let's go -20 to 20, and let's try that as a graph. It goes way up there for some reason. Okay, so again, I want to find, let's see if I can find that 0. Calc, the 0, and I'm trying to get over there. And I want to come down. Whoops, there it went right past me. There it is. So that's the left bound. I had to do a little bit of manipulation to get that to show up. Press enter. Go above it, and there's the right bound. Press enter, press a guess, so we'll press enter again. Oh, -3 that's a rational number. So -3 is that 0 right there, and that's in our list. It's right here. Okay, are these 2 rational zeros? Let's find out. Second calc, 0. Okay, we got to come back down and take a look at the left side of this one. I'm looking at this 0 right here. So I want to bound it. Okay, I just bounded it, and I want to check inside of those 2. And out comes -0.707070. That is not a rational number. It's not on my list. So that is a real 0, but it is irrational. And let's check this third one. Second calc, the 0. We're going to bound that one by being on the left side, which is here, and on the right side of that 0 here, and press enter, and I get positive 0.7070, whatever. That is not exactly 3/4. It's not one of these, so that is another irrational 0. So I have 3 real zeros, but only one of them is rational. So out of all 12 possibilities, I only have 1 rational 0. So the actual rational 0 is negative 3, as we just saw. Okay, let's do another example here. Let me come on up. And let me adjust my paper just a slight bit. Okay, we're going to come to here. Okay, example 2, list all possible rational zeros of this 4th degree polynomial. Negative x to the 4th plus 3x squared minus 4th. Okay, we want to remember that negative 4 is our constant. The factors of this are positive or negative 1, positive or negative 2, and positive or negative 4. This is a 1 in front, and the only factors of negative 1 are positive and negative 1. Okay, that's pretty simple. Okay, so possible rational zeros is going to be equal to, these are in the numerator. Remember, the factors of the constant are in the numerator. The factors of the leading coefficient are in the denominator. And those are all possible rational zeros. Okay, so what do we have? And again, I start with the numerator and do all denominators. Well, that's easy. I only have one denominator. So positive or negative 1 divided by positive or negative 1. Positive or negative 2 divided by positive or negative 1. And finally, positive or negative 4 divided by positive or negative 1. We can simplify this as simply positive or negative 1, positive or negative 2, and positive or negative 4. So we have 6, negative 1, negative 2, negative 4, positive 1, positive 2, positive 4. Total of 6 possible rational zeros. If this polynomial has any rational zeros, it is one of these 6. As a reminder, it may have no rational zeros at all. If it has one or more, it is going to be one of these or more of these 6. Okay, let's take a look. So I'll go into here. Let's see what our graph tells us. So let's turn it on. Whoops. Okay, get out of this one. Get to y equals and get out of that one. Let's put in negative x to the 4th plus 3x squared minus 4, and let's graph it. Remember, my window is a little bit strange. Well, let's go back to my standard window. We can see this a bit more clearly, so I'll go down to standard, negative 10 to 10, and here it is. Well, notice this 4th degree polynomial has nothing that touches the x-axis. So it has no real zeros. Never mind rational, it doesn't have anything that's real. All of its zeros are imaginary. So of all 6 of our possible rational zeros, none of them are actually zeros for this 4th degree polynomial. So as far as actual, using the graph, actual, I can't even say the word. Actual rational zeros, well, guess what? There are none. This 4th degree polynomial had no rational zeros. So there you have it, how to list all the possible rational zeros if there are any, and then how to check to see which ones are actually zeros.